Here long answer question चे answer keys. First question, describe the geometry of the young double slide experiment. हॅलो फ्रेंड्स, कशा आहात? आता आपण महाराष्ट्र शासनाने शालेय शिक्षण व क्रीडा विभागाने 2023मध्ये क्वेश्चन बँक पाठवली होती फिजिक्सच्या विषयाची. त्याच्यात आपण आन्सर की घेणार आहोत. लॉंग आन्सर क्वेश्चन्स वे ऑप्टिक्स या चॅप्टरचे बघणार आहोत. चला तर मग त्या क्वेश्चनकडे जाऊया. हे आहेत लॉंग आन्सर क्वेश्चन. याची आन्सर हे आपण पुढील प्रमाणे PDF स्वरूपात पाहूयात. हे लॉंग आन्सर क्वेश्चनचे आन्सर कीज. First question, describe the geometry of the young double slide experiment with the help of ray diagram. What is the fringe width? Obtain an expression for it. Write the condition of construction as well as destructive interference. Answer: let S and S1 and S2 be the two coherent monochromatic sources which are spread by a short distance d. They emitted light wave from wavelength lambda. Second, let D is equal to horizontal distance between the screen and source. Third, draw S1 into M and S2 into N is perpendicular to AB. OP perpendicular bisector of left since S1 into P is equal to S2 into P. The path difference between the wave reaching P from S1 and S2 is 0. Therefore, there is a bright point at P. Fourth, consider a point Q on the screen which is the distance y from the central point P on the screen. Light wave from S1 and S2 reaches at a point simultaneously by covering path S1Q and S2Q where they are semi superimposed. Diagram. Derivation. In a triangle S1MQ into bracket S1 into Q square is equal to S1 into M square plus MQ square into bracket S1Q square is equal to D square plus into bracket Y minus D by 2 in whole square. Equation 1. In triangle S2 into NQ into bracket S2 into Q square is equal to S2 into N into whole square plus into bracket NQ into whole square. Therefore, S2Q whole square is equal to D square plus into bracket Y plus D by 2 whole square. Equation second. Subtract equation 1 from 2. S2Q whole square minus S1Q whole square is equal to into bracket D square plus into bracket y plus d by 2 into whole square minus bracket d square plus bracket y minus d by 2 whole square into bracket complete is equal to d square plus into bracket y plus d by 2 whole square minus d square minus y minus d by 2 whole square is equal to y plus d by 2 in whole square minus bracket y minus d by 2 whole square is equal to into bracket y square plus d square divided by 4 plus yd bracket complete minus y square plus d square divided by 4 minus yd is equal to y square plus d square divided by 4 plus yd minus y square minus d square divided by 4 plus yd into bracket s2q in whole square minus s1q square is equal to 2yd. And therefore s2q plus s1q into bracket s2q minus s1q into bracket complete is equal to 2yd. Therefore s2q minus s1q is equal to 2yd divided by s2q plus s1q. Equation third. If y is less than d and d is less than d, then s1q is approximately s2q is equal to approximately d. s2q plus s1q is equal to 2d. Therefore equation 3 becomes s2q minus s1q is equal to 2yd divided by 2d. Therefore s2q minus s1q is equal to yd divided by d. Therefore, delta L is equal to Yd divided by d. Equation 4. Equation 4 is the path of the difference of the interference light wave. Pointer Q will be the bright if delta L is equal to n lambda is equal to 2n lambda divided by 2, where n is 0, 1, 2 dot 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 dot. Therefore, n into d divided by d is equal to n lambda is equal to 2n lambda divided by 2 from equation 4. Therefore, yn is equal to n y lambda divided by d. Equation 5. Equation 5 represent distance of nth bright fringe from central bright fringe. The point Q will be the dark point if delta L is equal to into bracket 2n minus 1 lambda divided by 2, where n is equal to 1, 2, 3 dot dot dot. Therefore, lambda n dash d into d divided by d is equal to bracket 2n minus 1 lambda divided by 2. Therefore, yn dash is equal to into bracket 2n minus 1 into bracket complete lambda d divided by 2d is equal to into bracket n minus 1 half lambda d divided by d. Equation 6. Equation 6 represent distance of and the dark fringe from central maxima fringe width. The distance between any two successive dark or any two successive bright fringe is equal. This is called the fringe width, and it is given by fringe width is equal to w is equal to delta y is equal to yn plus 1 minus yn is equal to y dash n plus 1 minus y dash n. W is equal to lambda divided by d divided by d. Thus both the dark bright fringe are equidistant and have equal width. Condition of constructive and destructive interference. The phase difference between the two waves reaching P from S1 and S2 is given by delta phi is equal to y d by d into bracket 2 pi divided by lambda. Therefore, since delta L is equal to y d divided by d, therefore conditions of constructive interference in terms of phase difference is given by delta phi is equal to n2 pi, where n 0 plus minus 1 plus minus 2 second, and therefore the condition for destructive interference in terms of phase difference is given by delta phi is equal to bracket n minus 1 half into 2 pi, where n is equal to plus minus 1 plus minus 2. Question number 2. Explain the for diffraction at a single slide with a neat ray diagram. Obtain the expression for width of the central bright fringe. Answer: for of diffraction due to single slide diagram. First, consider a narrow slide AB of width A kept perpendicular to the plane of the paper. The slide can be imagined to be divided into extremely thin slide or slide element. It is illuminated by a parallel beam of the monochromatic light of wavelength lambda, that is, a plane of wavefront is incident on AB. Second, the diffracted light of focused by the converging lens along a screen x by y. Third, the screen is kept in the focal plane of lens and perpendicular to plane of the paper. Fourth, let d be the distance between the slide and the screen. Fifth, according to Huygens principle, each and every point of the slide act as a source of secondary wavelet spreading in all direction. Position of central maxima. First, Let C be the center of the slide AB. The secondary wavelet traveling parallel to CP0 come to focus at P0. The secondary wavelet from the point equidistant from C in the upper and lower halves of the slide travel equal path from before reaching P0. Second, the optical path difference between all these wavelengths is zero, and hence they interfere in the same phase, forming a bright image at P0. Third, the intensity of light maximum at a point P0 is called as central or the principal maximum of the diffraction pattern. Fourth, for the line CP0 and angle theta is equal to 0 degree. Position of secondary minima. First, consider a point P on the screen at which waves travel in a direction, making an angle theta with the CPR brought to focus at P by the lens. This point P will be maximum or minimum intensity because the waves reaching at P will cover unequal distance. Second, draw an perpendicular to direction of a diffracted ray from point A. Bn is the path difference between the secondary waves coming from A and B. Third, from triangle AB and sin theta is equal to Bn divided by AB. Therefore, Bn is equal to AB sin theta is equal to A sin theta, since theta is very small. Therefore, sin theta is approximately theta. Therefore, Bn is equal to A theta. In figure, suppose Bn is lambda and theta is theta 1. Then the sin theta 1 is equal to lambda divided by A. Fourth, such a point on the screen will be position of first secondary minima. Minimum it is because if the slide is assumed to be divided into two equal levels, AC and BC, then the waves from the corresponding point of the two levels of the slide will have path difference lambda divided by 2. It is given rise to destructive interference at a point P which has a minimum intensity. If a point P on the screen is such that Bn is equal to 2 lambda and angle theta is equal to theta 2, then sin theta 2 is equal to 2 pi 2 lambda divided by A. Such a point on the screen will be position of the second secondary minima. It is general for nth minimum sin theta n is equal to n lambda divided by A, where n is equal to plus minus 1 plus minus 2 plus minus 3 nth order. 6. If y and d is the distance of nth minimum from P0 on the screen, then into bracket tan theta and d is equal to y and d divided by d. 7th, if theta and d is very small, tan theta and d is approximately sin theta and d is equal to n lambda divided by A. Therefore, y and d divided by d is equal to n lambda divided by A. Therefore, y and d is equal to n lambda divided by d divided by A is equal to n w. Equation first, where w is the fringe width. Equation first, given distance of the nth secondary minima from the central maxima. 8. The central bright fringe is spread between the first dark fringe on the either side. Hence, width of the central bright fringe is the distance between the center of first dark fringe on the either side. Therefore, width of the central bright fringe WC is equal to 2 lambda ID is equal to 2W is equal to 2 into bracket lambda D divided by A bracket complete. This is the required expression for the width of the central bright fringe. Question number 3. What is the interference? Explain the constructive and destructive interference with the help of a diagram. What is the coherent source of light? Answer. Interference of light is defined as the modification of the intensity of light into bracket large at some place and smaller at some place bracket complete produced by the superpositions of two or more light waves. Constructive and destructive interference. First point where the crest of one wave coincident with the crest of another waves, and where the through of one waves coincident with the through of another wave are points with a maximum displacement at this point. Displacement it implies that for each wave these are point of the constructive interference. Second, points where the crest of one waves is coincident with the through of point are point with the zero displacement. These are points of the destructive interference. Interference of waves diagram. Constructive interference and destructive interference. Two sources which emit a light wave from the same frequency having a constant phase difference independent of time are called as coherent source of light. इथे आपले सर्व लॉंग आन्सर क्वेश्चन्स आपल्याले आहेत. व्हिडिओ आवडला असेल तर लाईक करा, शेअर करा, सबस्क्राईब करा आणि बेल आयकॉन दाबायला विसरू नका, कारण नवीन नवीन अपडेट आपल्या चॅनलवरती तुम्हाला मिळत राहतील. धन्यवाद.